Hi everyone, thank you, and thank you so much for inviting me. So a few of you were also at the very first PopPaleo as I was, and I absolutely loved it. I got so much out of it, not just because I got to talk to people, but because I get to hear these talks from people who I wouldn't usually, get to interact with, history and art, all those kinds of things. So I'm really delighted to get to be here again. If anybody who knows me will not be surprised to know that I'm talking about mammals. However, I am just using them to illustrate kind of wider points about the way in which we talk about evolution and ecology, especially in deep time. So, yeah, we all know how evolution works now, right? We know that it isn't this old-fashioned idea of progress, of monkeys turning into humans, which is this kind of, the old-fashioned idea about how it works. We know that it doesn't work like that, that it's this branching, complex thing. There's some groups that just don't go anywhere, some groups that do, and it's all just kind of really more about serendipity and which ones just happen to be the best at a particular time to make it through. And I accidentally used the word best, but what I really mean is, because of course they're not getting better, are they? There's no progress here. We talk cladistically. We talk about crown and stem, we talk about derived and basal. So we all know how evolution works, don't we? Well, sometimes I see certain headlines and I do wonder how much we really do know about the way evolution works. And I apologize to the people who wrote this for picking on it. A Nat Geo article with the headline, "Which Animals Have Barely Evolved?" And I picked this as an example of the gulf, I think, that kind of exists between the fact that I think the public generally actually do have quite a good theoretical idea about what evolution is supposed to be, but when they actually, and not just the public, but scientists too, when we actually think about it and talk about it, we actually don't have a very good idea. We use terms and we think about it in a way that actually isn't really very accurate. And also, I should defend this weird animal question of the week. You could be saying, oh, well, it's just somebody's question, but that actually wasn't the question. The question that was asked, where is it, was what is the oldest surviving mammal that has gone unchanged by evolution? Which is actually a slightly better question than the one that then got turned into the headline by the editor or the writer. But this talk isn't, of course, about how the media distorts the message, which could be an entire workshop in itself. It's really about that gulf in our sort of understanding of the process of evolution. I mean, this headline infers that evolution can actually stop for some animals, and then by further inference that some animals are primitive compared to other animals. And that's one of the main themes that I want to kind of get at here. This idea of the primitive versus the advanced, which of course was a very Victorian idea. They were very popular, they were very keen on putting things in a scale from primitive things to advanced things, with obviously humankind being the most advanced. And we, of course, can kind of say, well, that was the Victorians, we've come a long way since then, but how far have we actually come? I really think that these ideas persist in the way that we talk about evolution and talk about ecology and extinct species in deep time. But I also the other theme I want to address here is about success. So people are always talking about things being successful. Oh, this is an incredibly successful group, or that animal is one of the most successful whatevers. What do we actually mean when we use the word success? What are we actually talking about? Now, clearly, I'm going to use Mesozoic mammals and small mammals in our modern ecosystem to illustrate this point, but I think it really applies to lots of different groups, and particularly to small-bodied creatures, so also things like herps, and also to insects and to many other groups. So a little background, of course, on Mesozoic mammals, and many of you will know this, but Mesozoic mammals, the first mammals from Triassic, Jurassic, or Cretaceous, they were Jurassic, and they were found at the same time as the first dinosaur, which was Megalosaurus, of course described in the fabulously eccentric William Buckland, his inaugural address as president of the Geological Society of London in 1824. And this is the sort of iconic image. And he described the beast in question, the Megalosaurus that is, as equaling in height our largest elephants, and in length falling little short of the largest whales. So huge emphasis on size, on grandeur, on wow. But in that same paper, there was also the first Mesozoic mammal mentioned. And Buckland was so kind of confused about what this might be, and also amazed. He said it was an animal not less extraordinary, and I would have hesitated to announce it, as it forms a case hitherto unique in the discoveries of geology. The specimen he was talking about, specifically, was this one, and it's a jaw. That's the back of the jaw here, and then the tooth row coming along, and it has since then been, the front of it's been taken off to look at the tooth roots. And it's in the Oxford Museum of Natural History. This jaw and many others like it were found in the Stonesfield slate. And Buckland was really kind of perplexed as to what it belonged to, and he consulted Georges Cuvier, who I'm sure you've all heard of, this famous, one of the greatest anatomists of all time, who confirmed, yes, indeed, this is actually a mammal. He believed that it was a marsupial. He thought it was basically like this little guy here. This is a Virginia possum. And so originally it was named Didelphis, but we now know it to be from a much, much earlier group, long before marsupials evolved. But it was really, really problematic for a couple of different reasons. Now, the first one was kind of geological. So these were coming from the secondary series. This is Jurassic rocks, known as the secondary at that point. And up to now, there had been other fossils found from these rocks, but they were marine reptiles and flying reptiles, and they were coming out of sediments that were laid down in aquatic environments. So the Victorians had this idea that at this time period, the Earth was a water world, and there really was very little dry land, and it was the age of reptiles. It was dominated by reptiles. So with this kind of picture in their minds, how could we have this little land-dwelling marsupial mammal living in the age of reptiles? Well, of course, the real problem was not so much the geology, but the theology. It was a theological problem for them, because they were still struggling with these ideas that had come in with, for example, Lamarckism, these ideas of change over time, and trying to explain the fossil record, and by inference that humans in some way might be related to animals, which, oh my God, what an awful thought. Couldn't possibly be animals. This was a really repugnant, of course, idea for the Georgians and the Victorians. So they had to try and find some explanation for this. How could we have mammals in the age of reptiles? So as we all know, the Victorians, great colonialists, great explorers, and they had by this point found out about monotremes and marsupials. So this is the platypus, I'm sure you all recognize. And when it was first sent back, of course, there was a little bit of confusion. What was it? Where did it fit in the scheme of life? So it got dissected by William Owen, by Sir Richard Owen. Sorry, I should really look at my notes because I'm probably going to start talking nonsense here. Yes, it got dissected, and he looked at the reproductive organs of the platypus to try and figure out where it fit. And he could see by comparison that it seemed to be somewhere between reptiles on one hand and mammals on the other. And again, through comparison, that it was slightly more like marsupials than it was like placental mammals. And so, a chain of descent. We can draw a line and we can say where one went to the other, not just a chain of descent, but a chain of primitive to advanced. And of course, I should have done another little arrow with a person, oh well, a man, up here. Yes. So, this explains it, doesn't it? We can now relax. It's okay that there's a marsupial in the age of reptiles because it's a primitive animal. These are primitive animals living alongside other primitive animals in the past. And you can see it, for example, in Buckland's Bridgewater Treatise. He's got this lovely little diagram, numbers 40 and 41, two little marsupial mice living in the secondary series along with a turtle. And I did share this in my previous paleo talk, and I'm sure you've seen it before, but it's so delightful that I just had to find a place to put this in. This is a Jurassic platypus being eaten by a crocodile with a pterodactyl kind of checking things out from up above. So this is a kind of common narrative, so it's fine. A few, you know, there can be mammals back this time because it's the primitive ones, it's not humans, don't worry. And I think the kind of subtext to this, and I'm not a historian, so I'm sure there's people in here who could talk a lot more knowledgeably about this, but of course we have to see this through the kind of colonial lens as well, which is that these animals come from parts of the world where there were colonies, and therefore they were viewed with the same kind of view that people took of the native people of those areas as well. They were viewed as primitive, as not as good as the stuff basically that came from the Western world. So hence this kind of reinforces why they were put at the bottom of this scale of mammals. Richard Owen also, in that same thing where he described the internal organs of the monotreme, he also talks about the brain. And he says in it, It is in mammalia that the brain is perfected, and we can trace through the different orders the increasing complication of this organ until we find in man it has attained the condition which so eminently distinguishes him from the rest of his class. And I think this kind of really, I like this quote because it really kind of captures, thank you, a really imperialist kind of colonialist attitude towards nature and towards biology and evolution. So in my last talk, I'm slightly embarrassed by the things that I was saying in that last talk, but I was far more interested in the visual side of things, the paleo art side of things, and I basically had just started to try and get people enthused about my research subject, and it's a challenge because of the reasons that I'm talking about just now. But also in thinking about this, it also, in the last 3 years, I've faced this challenge many, many times of trying to popularize them. And so therefore, I've started to think about more in terms of the historical side of things. Now, hang on, if I can just find where on earth I am in my notes, that would be really, really helpful. Right. Right, yeah, there we are. This is going to be much more helpful if I hold these. So fast forward to today, it's all about language, isn't it? We don't use those words anymore. We can look back at the Victorians and judge them and say, oh, well, they're using these terrible, terrible words. You know, we don't say this anymore. We say basal or stem, we say derive or crown. And that's good, obviously. It's more scientifically accurate. And it loses this kind of inference of things being better or worse. It loses that loaded language, and it also loses the idea that evolution is about improvement, which we realise it is not. However, I would argue, as a mammal paleontologist, that despite these changes in some of the words we choose, we actually still think about mammals in exactly the same way that Victorians do. And we still judge them. And it's most commonly seen in language. Now I'm going to pick on Owen again, because I just think his acidic writing style is just to be shared for the rest of time. So right from the start, the use of language was reductionist about small mammals in particular. So in 1871, Owen wrote this monograph on all of the fossil mammals that had been found from the Mesozoic to that point. Now you'd think a scientist writing something like that would be pretty pro-mammal. Yeah, well, Mesozoic mammalian life is low, insignificant in size and power. We see nothing moving of mammalian life save the low and the small, the rat-like, shrew-like forms of the most stupid and unintelligent order of sucklers. Yes, well, no punches pulled as usual from Owen there. But I would say the attitude actually kind of hasn't really changed. When we look at the many books and papers that come out now, popular science articles, public talks, Mesozoic mammals, they're still maligned through language, art, and simile. They lurk, they creep, they scuttle in the shadows, they are shrew-like, they are rat-like, they're verminous. They are the oppressed by the mighty. They are the butt of jokes. They're the primitive losers. Mammals didn't do anything in the Mesozoic. We skip over them. If they're lucky in these books, they get a chapter, usually more like a paragraph, until they got big. Because bigger is, of course, better. And getting bigger was an improvement. It was an advancement. It was a sign of mammal success. So what's success? Well, I think bigger is often analogous to success when we talk about it, but whether that's implicit or explicit. But of course, the biological definition of success is quite specific. I plucked this one out. Success in evolutionary terms is ultimately judged by an individual's success in passing on genes to future generations. So this is a very sort of specific biological definition of success. But I would say that very few people mean this when they're talking about an animal being successful. And I don't just mean the public or the media, I also mean scientists. I think we're actually using a far more colloquial idea of success. And I think success is usually talked about, it means one or more of four things. Persistence. So persistence in the fossil record over geological time. Abundance. And thank you, Darren, for this excellent example of abundance. It means geographical range. Are they found in lots and lots of different places? And then it means betterness. And that's a very vague one, but I think we have this idea that some animals are just better than others. Usually apex predators. I don't know why we seem to be so incredibly attached to things that eat other things. And I apologise to the shark lovers in the room. I picked on sharks, but that's because I think if you ask somebody to name a really successful animal group, a lot of people will say sharks, and I think they're right. But this is both the biological definition, but also in this colloquial way that I'm talking about success. And whether you're using the biological or the colloquial definition, you have to admit, small mammals are incredibly successful. So are insects, fungi, moss, bacteria. They're incredibly successful, but how often do you hear people talking about them in those terms? Not very often, I would say. So, of course, I want to tell you about Mesozoic mammals. And it's true, they reduced in body mass in the Triassic. So they did get small, they became much smaller than their predecessors, and dinosaurs did get much bigger. However, well, they went through something called a nocturnal bottleneck, hence this nighttime kind of scene, and it's a really negative term for something that actually should be viewed as a refinement, because they pioneered vertebrate miniaturization. They did something that no other animals could do, that no dinosaurs could do. They are microchips. They're night vision goggles. They're fuzzy little ninjas that are wielding shuriken teeth to reap their insect prey in darkness and stealth. These guys are exciting. Talking a lot more scientifically, smallness also drove a lot of the changes in their biology, which we are the benefactors of. And sorry, I think someone earlier said that we always have to talk about things in terms of the human, but, well, you know, it does help with SciComm. It's in these sort of modest predecessors that we see a lot of the changes that really have resulted in the sort of animal diversity that we know today. For example, recent papers showing that the origin of the regionalized spine in mammals is partly due to this period of time in the Mesozoic. But even more so, this paper is particularly excellent. So we have incredible hearing as mammals, our whole group, because of the incorporation of bones in the jaw into the ear, which has basically turned it into this exquisite amplifier. And it turns out that mammals becoming really small made that biomechanically possible. So if it wasn't for these little creatures, we wouldn't have Mozart's arias or Ariana Grande, whichever floats your boat. And finally, it turns out that over the last 20 years, we've found these complete body fossils of mammals which show that in the Mesozoic, they were also incredibly ecologically diverse, possibly as diverse and as important in their ecosystems as mammals of similar small body mass are in modern ecosystems. So they were clearly not inconsequential bystanders or just a food source, but they were key components of the Mesozoic ecosystem. And what's more, they are still here. And of the over 5,000 species of mammals on Earth today, 90% of them are still small. So this wasn't, being a small fuzzy scuttler was not some kind of evolutionary relegation. They weren't struggling to free themselves from under the yoke of dinosaurs. It was such a good way of life that they're still doing it 200 million years later, and very successfully, I would add. Now, as you can imagine, I see you all like this picture, yeah? As you can imagine, I get sent quite a lot of these by people. They seem strangely preoccupied with the fact that mammals get eaten by bigger things, which of course things have been eating other things since the beginning of time, but this seems to be quite an emphasis. And apologies to the artist here for picking on this one. And you're also probably thinking, wow, Elsa's got like no sense of humor about things eating her subject animals. But I do. I love dinosaurs too, and I love marine and flying reptiles. I love extinct life in general. The reason this bothers me is more to do with, I think, the negative SciComm impact I think it has for people like me who are trying to paint a more accurate picture of the way that life has progressed see, even I did it. Changed over time, not progressed. Oh my goodness. So speaking in terms of SciComm, I think some of the main problems that this creates is it encourages people to misunderstand how evolution works, as we talked about before, ideas of progress, that it's actually more complicated than that, but also how ecosystems work and how they've worked in the past, over geological time and into the present. And of course, it's the problems that they create in the present that are, I think, one of the biggest sort of issues with this kind of thing. So the benefits of paleontology is that we get this sort of set of goggles that lets us look through deep time and understand ecology and evolution on deep time scales. And that gives us a perspective on our current world and the way that we interact with ecosystems and the repercussions of our actions and the impact that our actions have on every part of an ecosystem. And I've talked about mammals because I know them best and I love them, obviously, but a poor understanding of how nature and evolution works, of course, it has a massive environmental implication and on many different groups. I mean, look, just for example, to the kind of most obvious ones, the impact of the loss of honeybees, of pollinators. And this one is here is the chytrid fungus, which not only has impacted populations of amphibians, but the entire ecosystem that they're part of. And I think this sort of lack of appreciation of the small and of the interconnectedness of nature now and in deep time has these huge environmental consequences. And then, yep, I'm drawing things to a close. Conservation, of course, conservation charities do really well at raising money for great big charismatic creatures, apex predators again, better than other animals. But it's very, very difficult for them to raise money for these little things because they are so kind of maligned and really seen as something that already isn't successful, so why bother saving it? Now, well, I was very careful when I chose the title for my talk. You may have noticed it's how we cling to tales of progress in evolution, not why, because if I'd said why, it would kind of infer that I was going to answer the question, which I'm not. I'm just hoping to discuss it with all of you, because I'm always musing about these things, and I think there's people in the room who know a great deal more about them than me. But I hope that in this talk I might have persuaded you that this way that we sort of persistently cling to tales of progress and view some things as being more primitive and more advanced is a societal and a psychological thing, and it's not actually a scientific way of looking at it. And I want to leave you with this cartoon, which is one of my favorites. And I think this is possibly some of the best sci-com that you're going to see about Mesozoic mammals, because nobody is better or worse or more progressed than anybody else. It's just about change over time and the serendipity of how high the bar happens to be at any particular moment in geological time. Thank you for listening.